We are Group 6 from Class CEEC1104A. Today, we are presenting our ECS268 Mini project, which is Sustainable Hollow Concrete Bricks. First, introduction. Before we dive into the technical details, let us introduce the team behind this project. First, we have NOOR SALIHA BINTI FAIZUL AZHA. Next is NOOR AINA NABIHAH BINTI ISMAIL. Joining her is NISA NAJIHA BINTI MOHD DAUD, shown here holding our initial prototype, MOLD. And finally, NOOR AZWA ARDINI BINTI AZMAN. To guide our project, we established 3 primary objectives. First, we aim to design and fabricate a functional mold suitable for producing 3 identical hollow concrete bricks. Second, our goal was to produce hollow concrete bricks from scratch using recycled concrete as a sustainable partial or full aggregate replacement. And third, we set out to evaluate the performance and structural integrity of the fabricated sustainable bricks through standard laboratory testing methods. Now let's look at background of the study. Traditionally, the construction industry relies heavily on mining natural sand and gravel to make concrete. This process uses up limited natural resources and creates a massive carbon footprint. At the same time, large amounts of concrete waste from demolition and school laboratories end up in landfills, taking up valuable space. To solve both problems at once, our project reuses concrete waste from past laboratory activities. We crush this waste and use it to replace new gravel. This approach offers 3 major benefits. 1, it reduces the carbon emissions caused by mining new materials. 2, it keeps heavy construction waste out of landfills. 3, it lowers material costs because recycled concrete is much cheaper than new gravel. Ultimately, this project directly supports United Nations Sustainable Development Goal 9, Industry, Innovation, and Infrastructure. It promotes efficient resource use and adopts clean, environmentally friendly technologies. Next, we will look into the methodology, the section of our project. Moving on to our apparatus, we categorized our tools into 3 distinct operational phases to ensure an organized workflow. First, for the preparation of materials, we utilized a hammer, plastic bags, and a weighing balance to properly process and portion out our raw ingredients. Second, during the mixing and curing stage, this is where the bulk of our hands-on tool came into play. We used a weighing balance for precision alongside a pail, a standard trowel, and a finishing trowel for handling the mix. Timing and consistency were managed using a stopwatch, a scoop, and a vibrating table to eliminate air pockets. Additional maintenance and setup tools included a towel, brush, oil, a hollow brick mold, a hammer, and a spanner. Finally, for the testing phase, to analyze the strength and dimensions of our final product, we utilized a compressive testing machine, a cleaning brush for post-test maintenance, and a measurement tape for recording exact dimensions. First, the preparation of materials. We use recycled concrete. We chose cracked or broken concrete as a replacement for gravel. Then the concrete was manually crushed using a hammer until the pieces reached roughly the same size as standard gravel aggregates. Next, for the mixing procedure, we precisely weighed all our 5 important components, which is gravel, recycled concrete material, sand, cement, and water. We started by pour the gravel and added the crushed recycled concrete aggregate. Then we added the sand and mixed them well. Next, we added the cement, then mixed, again, all the materials thoroughly. We made a hole in the middle. Then the stopwatch was started for 5 minutes and water was added gradually into the hole while the materials were being mixed until the mixture became smooth and uniform. The freshly mixed concrete was then packed into our brick molds and vibrated for the first time. The molds were then filled again, completely, and vibrated for the second time to ensure proper compaction. Finally, the surface of the concrete was finished to make it smooth and level. After that, the concrete was left overnight to harden. Now for the curing phase. After the concrete had fully hardened, we took it out of the molds at the sides, using tools carefully so the bricks would not break. Lastly, we remove the mold in the middle part of the brick. Next, we recorded the initial weight of each sample before immersion. The bricks were then fully submerged into a curing tank filled with water to ensure optimal hydration and strength development for 7 days. After 7 days of curing period time, we took the bricks out and the brick was wiped clean. Then we weighed them again for after curing. They were a little heavier because they absorbed water. Finally, we moved to the testing phase. First, we measure the length, width, and height of the selected brick. We placed the selected brick into the compression testing machine. Then we started the test and waited until the compression test was completed. Here is the side-by-side comparison of a structural brick before versus after. Compression test, displaying the predictable failure pattern under peak load. Next, summary of finding. The tested brick recorded a mass of 2.318 kilograms. In terms of mechanical strength, it demonstrated DAUD excellent load-bearing capacity with an ultimate load of 167.8 kilonewtons, resulting in a high ultimate load-to-weight ratio of 72.39. The actual measurements obtained after curing were 208 millimeters in length, 101 millimeters in width, and 71 millimeters in height. The hollow brick molds were not made by the students themselves, but were instead outsourced to outside carpenters, resulting in errors in length dimensions that were not detected at the initial stage. Next, the discussion. 20% of the coarse aggregates were replaced with recycled concrete to reduce environmentally harmful construction waste. Through compression testing, our brick recorded an ultimate load of 167.8 kilonewtons, which is a high peak load for a specimen with a light mass of 2.318 kilograms. The high load-to-weight ratio of 72.39 indicates a very optimal load-bearing structural efficiency despite the measurement error. Moving on to the discussion on material and testing limitations, we identified two main challenges. First, aggregate irregularity and air voids. Due to the manual crushing of recycled concrete, the aggregate produced was highly irregular in size. This reduced the workability of the mix and created trapped air void, which negatively impacted the density and compressive strength of our concrete bricks. Second, our testing sample limitations. We only managed to successfully test one brick sample under compression. Next, we move to conclusion. The objective of hollow concrete bricks with 20% recycled concrete was successfully achieved. From an environmental perspective, the sustainability impact is reduces construction waste, saves material costs, and conserves natural resources. To pave the way for future research, we propose 3 critical recommendations. First, mold accuracy. Improve fabrication accuracy to reduce dimensional errors. Second, sample size. Testing more brick samples to obtain more stable statistical average data. Third, mixed optimization. Studying variations in replacement percentages to find the most optimal strength and durability formula. Next, from our perspective as students, this project has had a significant impact and offered immense benefits to our learning process. First, it served as a bridge between theory and practice. We gained hands-on experience operating compression testing, machines, and mixing concrete, going far beyond merely reading theories in textbooks. Second, exposure to sustainable engineering. We learned about the vital role civil engineers play in environmental stewardship through innovations in concrete waste recycling. Third, we were able to hone our critical problem-solving skills. When we encountered sizing errors with the molds, we did not panic. Finally, the project taught us the true meaning of teamwork and time management. It is these soft skills that will prepare us to become graduates who are truly ready to enter the industry. Thank you for watching.